Hello, everybody. So today what we'll be doing is we'll be taking up the first question first, and then I will group the questions 5, 6, and 7 together, and then I'll finally take up 2, 3, and 4. And I'm just doing that to be a bit more organized because that's the way I think the concepts go in problem set number 2. So let's start with number 1. So number 1, what we are asked is we are given a sequence. The sequence is a(n) is equal to 1 over 1 plus e to the negative n. And we are told that this has a limit of 1 as n approaches infinity. Okay? So now there are two parts to this question. A gives you a specific epsilon basically, and it asks you to give you a k for which past that k is that you'll be in range of that epsilon. And the second one tells you to prove the base case. Now, hopefully what I just said is understandable to everybody, but if not, what I'm going to do is I'm just going to quickly run through what the terminology I just used means and why it means what it means. So basically what I was saying is let's imagine a graph. So here's our graph. And now we're going to pretend we have a sequence. So here's my sequence. It goes all the way like this, and it converges right over here. Now, this sequence has a limit. Let's put that limit in red. So it's going to go all right over here. And let's actually push that down a bit so that it looks more like a limit. So it looks like it's going to converge somewhere there. Perfect. And now, what limits are and the way they're defined, I'll just say that, is that past a certain k, so if we drop a certain arbitrary number and we're going to call it k, excuse me, Christmas. So we're going to have it k. So here's the line. This is k. So past this k, the distance that you're going to be from the limit. So let's say at k, you have a distance from the limit of epsilon. So this little distance over here is epsilon. That past that, you're only going to go closer and closer to your limit. So any n past k is going to be just smaller than the epsilon that you picked. Okay? So then for question A, it gives you that epsilon and tells you what k do you basically need so that past that you're always smaller than that epsilon. And then B asks you to kind of prove that it does in fact have a limit of 1. So what I'm going to do is I'm actually first going to prove the kind of the all-encompassing B, and then we'll see by plugging in A that it does in fact work. So let's start. So to prove that something has a limit, you first need to say that. So we're going to start with step 1. Let epsilon be greater than 0 be arbitrary. So more exact, I think I mixed up my words here, but it's basically let epsilon greater than 0 be arbitrary. Then for 2, now we're going to say let there be a k. K for epsilon greater than 0, for which an, so this is the term of the sequence minus L, which is the limit, is going to be smaller than epsilon for any n greater than k. And that is a wonderful n. I hope you really enjoyed it because I'm going to erase it because that looked like a horrible n. There you go. N greater than k. And what does this mean again? So we're saying that once we set that k and our epsilon is greater than 0, for any n greater than k, so for any next term, the difference between it and the limit is going to be smaller than our epsilon. Okay, cool. Now comes the fun math part. Okay, so what we're going to show is we're going to say 1 over 1 plus epsilon, 1 plus e to the negative n minus 1, which is our limit, absolute value of it is smaller than epsilon. Okay? Now what I'm going to do is I'm just going to start simplifying it. So 1 over 1 plus epsilon minus n minus 1 plus e to the negative n over 1 plus e to the negative n. Absolute value of that is smaller than e. Next, we're going to go 1 minus 1 plus e to the negative n over 1 plus e to the negative n, absolute value that is smaller than epsilon. That then simplifies just to e to the negative n, and it's actually negative. I'm sorry, there had to be brackets here, so it's going to be negative e to the negative n over 1 plus e to the negative n. Absolute value of that is smaller than epsilon. And just because I didn't mention, I'm just going to quickly mention it. The reason that they're absolute values is so that if we go back up here, it just basically means that the epsilon can be either on the bottom. It accounts for both the gap on the bottom and the top. So it doesn't matter which way you're measuring the distance. Okay, back to our problem. So then we know the bottom is always going to be positive here. So we know when we can remove the absolute value sign, just get rid of that negative. So we're going to get e to the negative n over 1 plus e to the negative n is smaller than epsilon. Finally, we're going to simplify this even further. So we're going to get 1 over e to the n over, it's going to be e to the n. So it's going to be e to the n plus 1 over e to the n. And this would be 1 over e to the n. 1 plus 1 over e to the n is just going to be e to the n over e to the n plus 1 over e to the n. And that's how I got this, is smaller than epsilon. Then we're going to simplify these two. So we're going to get 1 over e to the n plus 1 is smaller than epsilon. I'm just going to bring it up over here. 1 over epsilon is smaller than e to the n plus 1. 1 over epsilon minus 1 is smaller than e to the n. Then I'm going to ln both sides, so it's going to become ln 1 over epsilon minus 1 is smaller than n. And there you go. So now we kind of have a relationship between our n and our epsilon. And by doing this, we saw that there's an arbitrary, we can always have an epsilon, like epsilon and n have a relationship. And therefore, this kind of proves, because all of these are double implications, you can go both ways. I just didn't quite put them there, but you can imagine them there. And so that shows that basically you can get a relation between n and epsilon, and that means for any epsilon you have, you can pick that arbitrary n so that you know past where that relationship. So it's going to get smaller and smaller. So if we actually plug in before the number that we had, so it's 10 to the negative 6, we can figure out past which arbitrary k every n is going to be passed up. So if we plug in, instead of epsilon here, we plug in 10 to the negative 6, as we are supposed to do in A, we would get ln of 1 over 10 to the negative 6 is 10 to the power of 6 minus 1, and n. And so basically, this would give you an answer, and you would know that n has to be greater than that k. And past that, all of your epsilon you would get smaller and smaller. Hopefully that makes sense. If you have any questions, put them in the comments, and I will try to or ask me tomorrow.